welcome. My name is Justin Harbin. I am the founder of 21CL, the host of this online conference and this online session today. I'm joining you from Hong Kong, and I'm very pleased to be joined today by Ahmed, who's joining us from Egypt. I believe this is the first time we've had somebody lead a session for Egypt for this conference. So I'm very pleased to have him join today and lead his session on STEAM through programming, creating interactive games with Scratch. So with that, I'd like to hand it over to Ahmed to take us through his session today. Over to you, Ahmed.
Thank you, Justin, for that introduction. I am now showing my sharing my screen. Okay, let's start.
You're all good.
Great. Hello, everyone. Glad to be here with you all today. My name is Ahmed Ibrahim. I am Technical Learning Design Officer at Sanatec. I came today to share with you all how we can make learning computer programming fun, engaging, and impactful for our students. In my quick presentation, I'm going to share with you an overview of Sanatec, where I work with my colleagues on designing and developing educational content in the space of computer programming and its intersection with hardware, computer-aided design, and digital fabrication. And of course, I'm going to take you through how we can teach students computer programming in a STEAM way. Not the traditional way, but in a STEAM way. And share with you the recommended teaching methods we at Sanatec use to engage students in hands-on project-based comprehensive learning experience. Let me say that. So I hope you enjoy today's presentation. Sanatec is a social enterprise based in Egypt. Our vision is to democratize innovation and manufacturing in the MENA region mainly by growing a community of makers and enhance their experience through offering educational programs and different technical services. We have three main products. FabLab Egypt, which provides access to digital manufacturing tools and machines and expertise in 6 cities across Egypt. Sana Academy is the educational arm of Sanatec, offering educational programs for audience from different backgrounds, personas, and age groups. Last but not least, Maker Faire Cairo, which is an annual festival that gather all makers in one place, attracting like over 10,000 attendees each year. One of our flagship programs at Sana Academy is Maker Diploma and Girls Make, where the student go through a 3 months learning journey. They learn computer programming and its intersection with hardware, computer-aided design, digital fabrication, and how to use 3D printers and laser cutter machines and so on. And at the end of the program, they are working on integrating all of these modules in a single smart device where it will be their final project. And throughout the journey, they are working on documenting their work and so on. In today's presentation, we will be also talking about the teaching techniques we are using in our flagship programs and our other educational products to teach all of the students computer programming in a funny and engaging way. So today's presentation will be mainly talking about this topic, inshallah. Now, let me show you how we teach our students computer programming in a STEAM way. Let's start by exploring the term STEAM education. The core of STEAM education is to create learning experiences that encourage students to innovate and apply these disciplines in an integrated real-world context. When it comes especially to programming, STEAM transform transforms it from a series of steps to follow into a creative process, into a problem-solving process. I'm not following a guide of steps, where students design solutions to real problems. For example, building games that address social or physical challenges encourages students to see programming as a tool, not a destination, as a tool I can use to make a positive impact on the society or on the people around me. So the goal is not to learn programming in general, but the goal is to look at programming as a tool we are using to build smart solutions or technological solutions. So we are seeing programming just a tool we are used to solve problems. On the other hand, the traditional way of teaching programming often involves show and tell technique, where teacher demonstrates each step and the students simply follow along. While this can work, it doesn't give students the chance to think critically, innovate, or develop their creativity. The students only following along with the teacher to apply a certain procedure of steps to build something. But as a student, I cannot see the purpose behind that, or the problem I am solving, or the solution I am building, and so on. But with STEAM education, we aim to turn programming into an engaging, hands-on problem-solving activity rather than just a series of steps to copy. The STEAM learning process always starts with a real-life problem or a challenge that we all work together, hands in hand, to propose potential solutions for that challenge or for that problem. One big problem facing young people is the increasing of screen time, which has led to a decline in physical activity. We have all seen how much time students spend on their phones, tablets, or computers. Since physical activity is crucial for physical and mental well-being, so can we tackle this issue in a fun and educational way? Instead of using our screens for just scrolling reels and so on, how can we optimize this screen time to solve a real-world problem young people are facing? And at the same time, we are enjoying the process of solving the problem. We are making something that we are really interested in. So we can say like we are building a game in a fun and engaging way, and at the same time, this game is solving the issue or the challenge. What if we could use screen time to actually encourage physical activity? Imagine a game where students have to move and interact physically to play. They would get to have fun while staying active. I'm still using my phone and my computer. I'm playing a video game. I'm having fun, and at the same time, I'm doing physical activity. I will show you a demo of the game we will be discussing today. It's built using Scratch programming and has a unique twist. It uses computer's camera to detect motion, so players have to move to control the game. Let's take a look at the game so we can visualize what I'm talking about. I will open this game. I will share this tab instead. I'm now opening Scratch platform, and I will run the game so we can see it in action. Okay, let me. That's it. It's a simple game that utilizes the laptop camera to detect motion, to pop as much balloons as I can to get the biggest score I can. So it's a game that encourages young people to play, have fun, make a challenge between a classroom and so on. And at the same time, we are moving and making gestures and body movements and so on. I will get back to my presentation. As you can see, this game makes player get up and move. It's built using Scratch and the video sensing extensions. We are going to talk about this extension like 5 and 10 minutes later, which allows us to use the camera to detect motion and gestures. Imagine the excitement of creating something like this with your 10, 15 students in a classroom. We all moving and making body movement to interact with the game, to collect as much score as possible, and to pop as much balloons as possible. So it's really exciting inside the classroom. Scratch, let me give you a quick brief about Scratch. Scratch is a blog-based, beginner-friendly programming platform with a feature called video sensing. This is an extension that turns the camera into a motion detector, which means that we can use gestures and body movements as inputs to control the game. And instead of using my mouse or my keyboard to interact and control the game, no, I'm physically standing up and moving and making gestures as an input to the game to control. This adds a whole new layer of interaction and opens up creative ways to build engaging and active games. Okay, there are two different approaches to teaching this kind of project, or teaching this kind of building a computer game or building a computer program. With the traditional approach, we guide students step by step through creating the game. They would follow along, as we said before, build the game exactly as I showed them. I'm telling them, do this step, they will follow. Do the second step, they will follow. Do the third step, they will follow, and so on. I show them, and then the activity would end simply like that. That's it. No innovation, no creativity, no critical thinking, no problem solving, and so on. But with the STEAM approach, we go deeper in the problem at the first place. We help students to understand the problem and its context through interactive discussions, brainstorm their own ideas based on their understanding for the game, and then we provide just the basics of the technology. We teach them how to use the technology or the computer programming or the specific computer programming language to build a solution. So they get to experiment that technological tool, create and take ownership of the solution. They are the one who owns the solution, and they are the ones who have to build it and test it and do all of the stuff. So it's more engaging and empowering approach when the students are taking the lead or the ownership of building a solution for a specific problem, that they are built an empathy towards it. With the STEAM approach, we are seeing programming as a tool, as I said before, that helps us to build different solutions. Unlike the traditional approach we talked about earlier, we are seeing programming as the main goal that we want to achieve. We only want to learn programming, but we don't understand as students, why do we need to learn programming? What will I do with programming? And so on. But the STEAM approach solves this issue. In the STEAM approach, we are focusing on the problem, we are brainstorming, we are getting up with different ideas or different solutions that we can implement to solve the problem and so on. So we are seeing the cause from the start that answers the question why are learning programming and what I will do with computer programming. So that is the main difference between the traditional teaching way and the STEAM teaching way. In the STEAM approach, we start by helping students empathize with the problem. As I said before, in this case, we would discuss the impact of screen time on physical health. Next, we ask them to brainstorm game ideas that encourage movement. This way, we are not just building something in general without reasons, but they are solving a meaningful problem through programming or through building computer games. But to help the students to build smart technological solutions, we teach them the basics of Scratch computer programming and the fundamentals in a project-based learning experience, and they get to design their own versions of the game based on the understanding they have built to the problem. It's their creativity and the problem-solving skills that drive the project forward, not building something in general without any context. After the students well understood the problem, built an empathy towards it, and designed their own version of the games, we proceed to the next phase, which is the prototyping phase. So we started the cycle by understanding or by introducing the problem or the challenge we want to solve, and will understand the problem or the challenge. The students have to build an empathy towards it and understand the context of the problem and the challenge. Then they need to ideate to come up with different ideas that can solve the issue. After that, we proceed to the next phase, which is the prototyping phase, where the students get introduced to new programming concepts and apply it to build their solutions that they came up with in the previous phase. Let's do a quick hands-on example of how we might go about building this game in a classroom. Let's say that we are going to build the Popping Balloons game we saw earlier. Such a game is a bit complex, to be honest. It includes different new programming concepts that will be hard to tackle all at once with the students. So we are going to divide the game into 3 main phases. Let me say that. Each phase tackles a new programming concept at its own and introduces it to students. And we will be tackling each phase at once. So we divided the big number of concepts in the game into a fewer ones. Each phase covers and introduces a new programming concept at its own. So it will be easier for the students to understand each programming concept at its own inside a full closed phase. So let me say that the first phase can be building the game visuals, deciding on the characters and so on, and make it moves simply, very simple moves. The second phase can be introducing the video sensing extension and building the game logic. The video sensing extension, the tool that allows us to use our computer camera or the webcam to recognize body movements and gestures to control the game, as we saw earlier in the game demo. The third phase, tracking players' score and adding the game timer. It's this phase only tackles like 2 or 3 new programming concepts, and the second phase also tackles like 2 new programming concepts. The first phase tackles like 2 or 3 new programming concepts. So each phase is focusing on a set of new programming concepts as its own and introduces it and explains it to the students and allows them to apply on it inside a full closed phase. Then we proceed to the next phase. Then we proceed to the next phase, and so on. But because of presentation time, we are going to focus on the second phase only, where we introduce the video sensing extension and building the game logic and the fundamentals of the game logic. The teaching technique or the teaching approach we will use in the second phase will be applied on the other phases. It will be applied on the first phase and the third phase and the fourth phase and so on. So we are taking a hands-on example on one of the phases, but the same teaching technique will be applied on the other phases as well. But first, here is a question. What is the teaching approach we will apply to cover each phase with the students? What is the teaching approach me as an educator or a teacher I will use to introduce the new concept to the students? I will use the traditional way or the STEAM way, and if the STEAM way, how I will do that? First, remember we are at the prototyping phase. The students already well understood the problem. They brainstormed and came up with ideas. And now we are prototyping these ideas. And we are working with the popping balloons game as an example. So that is the game we will be building. And that is the phase we are in, the prototyping phase, after understood the problem and came up with ideas and so on. So to teach students a new programming concept, we go through these 4 stages showing up on the screen. We start by a demo for the final output of the phase that we want to build. Then, when I say a demo, it's like the demo I did 10 minutes earlier. I'm opening the game or the final output that I want to achieve at this phase. I interact and use it. I explain it to the students so the students understand what I want to achieve by the end of this phase. What me as a student have to do to build or to build the computer program that covers the current phase I am working at. After the demo phase, we explain the new programming concepts that help the students build the current phase program. We build with them a very simple program explaining the new programming concepts that we will use to achieve the final phase program, but not showing them the full phase program solution. So we are explaining new programming concept, we applying it inside a very, very simple game, showing the new concept in action, but we are not showing the full phase program solution, and we will know why now. After that, we challenge the students to build the phase program themselves. And it always has like a twist or something extra than the explain phase that the students have to figure out themselves to build the correct program. So the extend phase, we are giving the students as base to apply what they have learned in the explanation phase, but with something extra on the program we built in the explain phase. So the students have to think and solve a simple challenge they are facing in building the computer program. So we encourage them to do a search on the internet, to experiment with different programming blocks, experiment with connecting different blocks with each other to build a certain logic and so on. So always the extend phase has something extra than the explanation phase that students have to figure out themselves. Lastly, we reflect on their work and provide the correct solution for the current phase. After we gave them the space to build the program themselves in the extend phase, at the reflect and share phase, we share with them the correct solution, how to build the computer program, because if one of students is struggling or something, we provide him or her with the correct solution. And make sure that everyone will understand the new programming concept and can apply it in a project. We call these 4 stages a full closed cycle. We go through all of them with the students on every new programming concept we introduce. And this full closed cycle that consists of these 4 stages we talked about is inspired from the 5 E's methodology. Okay, let me start with the first stage in the 4 stages, or in the full closed cycle, the demo phase. The demo phase main goal is to help the students understand and visualize what we actually want to achieve by the end of this phase, as I said before. So the teacher opens up Scratch environment and demo the final output that each student need to achieve. The students watch the demo and ask questions if they have any. Let me show you that in action. I will open that demo. Let me share this tab. Now I'm showing my Scratch environment tab, and that is the demo that the teacher have to share with the students, so the students understand what I have to do in this phase. So let me run the program as a teacher. I am the teacher now. Okay, the program is running. There are balloons that appearing on the screen. I'm trying to popping the balloon by moving my hand and making body movements and so on. So that is the demo that the teacher has to do with the students to help them visualize the final output of the current phase. Let me go back to my slides. After showing the students the current demo, the current phase demo, we proceed to the next phase, which is the explain phase. The explain phase main goal is to introduce the new programming concept to the students and make sure that they all will understand it. So the teacher explains the new programming concept to the students and apply it by building a simple computer program that shows the new concept in action. But as I said before, without showing the full solution for the current phase, because the students in the next phase will do it themselves. And in the explain phase, the students watch the explanation that got introduced by the teacher and apply with the teacher in a very simple game to show the new programming concept in action. Let me show you that in an okay, I'm now sharing my Scratch tab, the explain phase, where the teacher opens up Scratch with students, showing the interface and explaining to them how to use the main, or how to, the teacher explaining the new programming concept to the students by applying it in a very simple game. So let's say the game we want to build now is when I touch the balloon, it will move a certain number of steps. That's it. That is the explanation we will do to introduce the new programming concept, building a very, very simple game. When I touch the balloon with my hand, it will move a certain number of steps. So let's build that. The teacher will explain the students the function of the show code block and how can we get that block. So we are moving to the looks category, and we will see a block named show. I will drag and drop it in the workspace where I connect the blocks with each other. So after that, I need to use my video sensing extension to detect or to recognize the body movements and hand and body gestures and so on. To do that, we have to insert the video sensing extension to my project. I will do that by clicking on that extension. It will appear in the categories here. Then, as a teacher, I will explain the function of the when video motion is greater than 10. What is the function this code block do and how it works and so on. I will explain that to the students. Also, I will explain to the students the function of the turn video on code block, what is its function and why we need to use it in our project. And then I am assuming here that the students already knew the if condition and operators and so on. So we are in this phase. The conditioning is not a new programming concept for the students. I'm assuming that they have saw and understood it from previous lessons. After explaining the turn video on code block, I will use the forever loop to run this code block, and I explain to them. Let me zoom out a little bit, and I explain to them the function of video motion on sprite code block, what its function and how it works and so on. And after explaining all the new programming concepts, and mainly the new programming concept in this phase is the video sensing extension and its code blocks. It's a new tool or it's a new extension we use for the first time in our project to build a computer program. So our main focus in the explanation will be at the video sensing and its code blocks. After explaining the main code blocks of the video sensing extension and building this simple program showing these code blocks in action, we run the game to test it and see when I touch the balloon, it moves a certain number of steps. That is the very simple project that the teacher will build with the students to show the video sensing extension in action. After explaining the new concepts and the video sensing extension and applying it in a very simple project, let me go back to my presentation. After that, we proceed to the extend phase. But before talking about the extend phase, let me remember you that in the demo phase, we demoed the final output that we want to achieve by the end of this phase. In the explanation phase, the teacher explained all the new programming concepts to the students and applied it inside a very, very simple game. In the extend phase, the teacher, the extend phase main goal is to give the space to the students to apply what they have learned. In the explain phase and solve the challenge that will be introduced by the teacher. The challenge here is to build a program that recognizes the body movement on the balloon sprite. If a movement is recognized, the balloon should disappear and reappear again after 1 second, but in a different random position. That is the challenge that students have to solve. The teacher introduces the challenge to the students, and the students have to apply what they have learned in the previous phases to solve that challenge themselves. To solve this challenge as a student, I will need to use some different code blocks inside the Scratch environment. to be able to solve it. So as a teacher, I can or I could give my students a hint like random position code block. That's a hint, and the students have to use that hint to figure out what is the computer program that solves this challenge. Okay. Now I'm sharing my Scratch environment tab. In the extend phase, students have to open Scratch themselves and build the computer program that solves the challenge we saw earlier. So the students now have a hint. The hint says random position code block. So as a student, I will build a simple pseudocode for the challenge that to help me build the computer program. I will get the basic code blocks from their categories and connect things together. And I will use the hint that the teacher gave me to figure out how can I move the balloon when I touch it to a random position automatically without specifying hard-coded the number of the steps that the balloon have to move when I touch it. I don't need to make that. I don't need to use the basic move steps code block, but I have to use another code block that allows me to tell the balloon to go to a different random position when I touch it. So to figure out that, I will use the hint that the teacher gave me and search for the code blocks. And I will find a code block say go to a random position. So that code block may be from its name may solve the challenge that I'm working on. Okay, so I will get the code block and connect it in its place inside the forever loop and inside the if condition. Most of the program we built with the students in the explain phase, and they all understood how to build it. But in the extend phase, there is something extra that they have to figure out themselves, which is the go to random position code block. So it's a new challenge for them to solve. It is not like the explain phase that the teacher explained to the students earlier. So it's always extend phase has something extra that the students have to figure out themselves. So that is the extend phase. We gave the students the space and time and a challenge to solve themselves and figure out the correct solution for it. After the extend phase, the reflect and share phase come. The main goal of this phase is to give the students a space to share their solutions with their teacher and peers. The students share their solution with the teacher and peers. The teacher provides feedback to the students according to their solutions and provide the students with the correct solution at the end and make sure that they all will understand the solution and how to solve the challenge. Because as I said before, if there is a student or two struggling in figuring out how I solve this challenge, in the reflect and share phase, the teacher shows a correct solution to all of the group and make sure that everyone in the group will understand that and can apply it themselves in a computer program. So by passing through all these 4 stages or 4 phases, we can say we have completed a full closed teaching cycle that introduces a new programming concept and it challenges the students to test it and test their understanding and apply on a real world project. So by passing through all these phases, we have completed a full closed teaching cycle. The demo phase, the explain phase, the extend phase, and lastly, the reflect and share phase. From our experience, this is the recommended approach of teaching students computer programming. And that is exactly what we do in our educational products. And one of them is a book called Fitness Games Book, where we use the same learning approach to teach students computer programming and help them build different computer games that encourage young people to move and make physical activity while they are playing and having fun and engaging with each other. Also, we use the same teaching approach to teach students about different topics like hardware programming, computer programming, computer aided design, and digital fabrication, and so on. We immerse them in a project-based learning experience that is focused on their problem-solving skills and their innovation and creativity. So we are not telling them exactly do this and do that. And instead, we are giving them the space and the tools that can help them build innovative and creative solutions or technological or smart technological solutions to solve a real world problem. So the thing that so the students are taking ownership on their solutions and moving forward to achieve that solution. Wrapping up, in today's presentation, we covered what STEAM education is and its importance, the benefits of using computer programming to solve real-world problems, how to teach programming in a way that goes beyond traditional methods, a hands-on example to get you inspired where we opened Scratch, we took a look at the popping balloon simple game, and we built together a very simple program that achieves or that solves a simple challenge. Lastly, I would be happy to answer any questions or inquiries. Please feel free to contact me. Here's my email address, and that QR code will get you to my LinkedIn account. And thank you so much for listening. Thanks, everyone, and thanks, Justin.
Thank you so much, Ahmed. Really appreciate you sharing today and doing the live demonstration too. That's always it doesn't always work, but it was great. It really worked really well. I thought for a minute you were showing a video, but then I realized actually it was you controlling the app. So that's really good. What age group of kids are doing these projects?
Sorry, can you repeat that again?
What are the age group of the students that are doing these projects?
We mainly working with in this kind of learning approach or this kind of game or this kind of content. We targeting students between like 8 and 13 years old.
Okay, that's great. Yeah, and what for the time period from the beginning part of that design cycle to finishing, how long is that time period?
On the development and designing level of the content itself, it takes time because at the start we have as a designers and development team to build an empathy and with the audience that we are targeting with the content. We have to make like simple interviews and talking with this age group to analyze their needs and what they are interested in and what they are like to see in educational content. After the learner analysis process, we work on designing the outline or the rough structure of the content of the workshop or the educational book or something. After that, we take each headline or each topic and divide it into a set of activities where each activity has to apply that learning, that teaching approach or the 4 phases we talked about. After that, we develop the activities itself that students will build throughout the learning journey. So it takes like weeks or months to develop or design something like that. It's not easy. It takes some time, but at the same time, you can see the result of it with the students. They are interacting with you and playing and having fun, engaging, and at the same time, they are learning new concepts and tools and so on.
I'm sure the kids are really motivated by what they create. What are some of the most surprising or interesting things you've seen students create using Scratch?
Always brainstorming and coming up with ideas phase. Always the students come up with really, really interesting ideas that you as an adult cannot think of. It's very innovative and creative games ideas. So this phase, especially for me, I found it the most interesting phase for me. I see many different ideas, many different creative and innovative ideas that I cannot think of. And they implement these ideas in a very good way, technically on a programming level. So it's the most exciting phase for me personally.
Yeah. Do you often find students will go away and work on it in their own time and then come back with, having made some advancements because they get really excited by it?
Yeah, sure. After we finish the session time, when they go back home, they almost all of them opens Scratch at their home and making some tweaks and edits on their games, adding some colors, new characters, different backgrounds, adding different characters and so on. So they always make tweaks on their games. And in the next session, they came with these games and these tweaks proudly to show off with the teacher and their bees and look what I made at home. So yeah, almost all the time.
That's wonderful. Yeah. And this last question for me is, so you're in the block-based coding for kids this age. Do you what's your next step beyond that? Like when the kids are moving, getting more advanced, what's your next environment that you move kids into?
Actually, we see hardware programming is very interactive. The student at this age gets really interested when they see like a board has some LEDs lights up and so on. When I do some programming on a Scratch or on a block-based platform like Scratch, like MBlock, for example, or Vectorblocks, for example. These are different block-based programming platforms like Scratch that we saw earlier. So always linking hardware programming with computer programming to build physical hardware projects that do different actions. Always, for me, the next phase for computer programming alone or standalone. Connecting the hardware with computer programming to make physical projects includes sensors and different actuators and so on. Always adds a new layer of creativity to the learning process, so students get more space. They can build things that moves, build things that sense the environment around them and so on. So we see hardware programming with block-based programming always the next we can go.
That's great. Well, thank you very much, Ahmed. Really appreciated you sharing today. Very clearly thought out and well presented. So I appreciate your time. And thank you for being our first presenter from Egypt. That's fantastic.
Thank you, Justin. Thanks for having me.
All right. Have a good evening. Bye.
Bye.